Okay, we're going to look at the idea of multiple scaling. It'll become apparent to you what I mean by this as we go through the instructions for this problem. Now, this is a problem as a supplement after the capstone project, and it's assumed that you have a really good picture of how to manipulate these graphs and how to get y factors and powers and find values of a and so forth. So let's just assume that we have a graph of frequency versus length for a pendulum obtained, let's say, in the lab with pendulums up to about 3 meters long. And from all our work, we've found a y factor of about 0.62. I'm not saying whether that is the y factor or not that you would get if you did this experiment really carefully, but that's the y factor we're going to use. And that leads to a power that's very close to the negative 2/3 power. Negative 0.667 would be negative 2/3, and this is about negative 0.688 or something like that. So very close. So we're going to assume the power is negative 2/3, meaning the reciprocal of the cube root of the square of the length. And if you don't understand what that means in terms of this, you really need to review your laws of exponents, because that's something everybody should understand, having been through just Algebra 1. But I find that students don't understand it very well, even when they come to college. Take some advice and make sure you understand the laws of exponents and what I just said and how it applies. Okay. But for right now, I mean, for the purpose of this exercise, you don't really have to understand that. You can just plug it in. Anyhow, we have then a frequency versus length, again, model. Frequency is a times L to the negative 2/3. So we have this graph, which leads to this factor, which leads to this power, which leads us to this model, in a process that you've seen and should be very familiar with by now. Okay, now, to test this model, which we did in the lab, we want to extrapolate it. So we're going to use a much longer pendulum. We go out and find a couple of really tall towers. One of them happens to be tall enough that we can make a 100-yard pendulum, and another one's really tall. We can make a pendulum 1/10 of a mile long. Okay, so we observe and take observations. We do a count, and we determine that the frequency here is 3.2 cycles per minute. Now, we're probably going to count this for longer than a minute. If we go to all the trouble of building pendulums in these towers, we're probably going to count this one for at least an hour, maybe a day. And of course, if we go that long, we want to do something besides manual counting, because we're going to go brain dead after a few minutes. Okay, so we have anyhow this and this, and we could probably actually get this to at least 2 significant figures. And counting for an hour, we could actually justify 3, maybe even 4 significant figures, but we have the air and air resistance and stuff like that, and it's going to throw things off a little bit. So 2 significant figures, maybe 3, but we'll just use 2 for right now. Okay, now all I want you to do with this, here's our graph. Now use your own graph, don't use this thing, because I didn't even attempt to make this graph fit this y factor or this power. Okay, I just slopped the graph up there. But using your own graph of the 0.62 factor, which you can easily construct, 0.62 is pretty close to 5/8, and 5/8 is something you can actually construct. So let me just say that, that's about 5/8. Okay, so that might be helpful, and for a reference graph, that would be close enough. Okay, first thing I want you to do is locate this first data point on the graph. Now, you can put this first data point any place you want. I'm going to put it, you don't want to put it too low, but you don't want to put it too close to the x-axis either, and you're kind of fighting yourself to determine where that's going to go. I'm going to put that about here. Okay, now, and I'm actually giving you a little hint to get you started, because I don't want to leave you confused about what to do. This should be obvious, and you should already know to to have done this. So this point is 3.2, and I don't put any units on it because I've already labeled the frequency. Actually, I'm starting to label this thing backwards. Unfortunately, having one of those mornings, maybe I'm not totally tuned in, but that's not your problem, it's mine. Okay, so this would be what? 100 yards. .2. I put the yards on this because I have not labeled a scale here, because of course I've got two data points with different scales. Okay, so I have 100 yards, 3.2 here, which means that 3.2, meaning 3.2 cycles per minute goes here, and 100 yards is going to go here. Now, given that, we can completely label this graph in terms of yards. We can completely label this in terms of cycles per minute. So, we label the graph according to our first data point. There's 100 yards. Now, where's 200? Where's 300? Where's 50? Where's 150? How are you going to label in terms of the 3.2? Then, we label again according to our second data point. Now, our second data point, we have the same scale for the frequency. So wherever we put the point on the graph, we can't just pick any point on the graph anymore. We have to pick a point where the frequency is 2.3 cycles per minute. And since we've already got our scale, well, we find wherever 2.3 is on this axis, we project over here and project down, and that's where our tenth mile is going to go. So you want to do that. So we want to, and then you want to complete labeling, and you do a second labeling. Okay, like you got your labeling in terms of yards here. Just below that, you can put your labeling in terms of miles. Okay. Having done that, I want you to use this dual labeling to determine how many yards there are in a mile. Once you've done the dual labeling, it should be obvious how you get this, but I'll give you some hints in a subsequent video, just in case. Okay, then you want to find A for the first data point, okay, for the first labeling, okay? What is the value of A that would correspond to the first data point, and what's the value of F that would of A that would correspond to the second data point? Okay, compare those values of A, and again, see if you can draw conclusions, especially related to the question of how many yards there are in a mile. Now, you can look up on the internet how many yards there are in a mile. It's possible you even know how many yards there are in a mile. It used to be common knowledge, not so much anymore. So that's all I'm going to give you right now, but I'm going to follow up with some hints just in case you have a lot of trouble getting started. But before you look at any hints, as usual, give this some serious thought. See if you can understand. Read it, think about it, think about what you might do, go to bed, get up the next day, see if now it becomes clear, and if not, then it's maybe time to look at a hint. And if you're totally lost, I'd go back and do some review. This being a supplementary exercise might or might not be really required, but it's an excellent exercise, I think, to give you a lot of additional insight.